Hi guys, in this fifth video on our series on laws of indices, we'll be looking at fractional exponent or laws of fractional exponent. This rule states that when the power of a number is a fraction, the numerator is a power and the denominator is a root. Whenever you come across any indices whose exponent is a fraction, what this rule simply states is that the numerator of that fraction is a power and the denominator of that fraction is a root. So if we look at an example that we have here, a to the power of b all over c. So here, b is a power and c is a root. This can be written as c root of a to the power of b. So this is just an alphabetical representation of what we have. So we are going to use this same principle to solve these questions that we have here. So the first one is 8 to the power of 2 all over 3. 8 to the power of 2 all over 3. So let's see how to solve this question. So we have 8 to the power of 2 all over 3. So this rule states that this base has a power of 2 over 3, which is a fraction. Following this rule, the numerator, which is 2, is a power, and the denominator, which is 3, is a root. So we can rewrite this expression as cube root of 8 to the power of 2. The denominator is 3, which is a cube root, and the numerator is 2, which is a power of 2. So what is the square of 8? The square of 8 is 8 multiplied by 8, which will give us 64. So we have cube root of 64. What is the cube root of 64? The cube root of 64 is a number that will multiply itself 3 times to give you 64. And that number is 4 because 4 multiplied by 4 is going to give us 16. And 16 multiplied by 4 is going to give us 64. This means our final answer is 4. Okay, so let's go to the second question. B, we have 8 over 27 to the power of 2 all over 3. So following the same process, we know that 2 is our power, and we know that 3 is our root. So we're going to write cube root of 8 all over 27 all to the power of 2. Okay, so you can either find the square first or find the cube root first. But I decided to find the cube root first so that we will not have large numbers. If we decide to find the square first, square of 27 is going to give us a large number. So let's look for the cube root first. Cube root of 8 is a number that will multiply itself 3 times to give you 8. And that number is 2. 2 multiplied by 2, 4. 4 multiplied by 2, 8. And 27, the cube root of 27 is 3. 3 multiplied by 3, 9. 9 multiplied by 3, 27. So we have 2 all over 3 square. What is 2 all over 3 square? The square of 2 is 4, and the square of 3 is 9. So this means our final answer for this particular question is 4 all over 9. Simple. Okay, so let's go to the last question for this particular tutorial. We have 0.027 to the power of 1 all over 3. Okay, but observing this particular question, we can see that this is a decimal. So for us to continue solving, the first thing we need to do is convert from decimal to fraction. So we move the decimal point 3 times, 1, 2, 3. So this becomes 27. But since we moved it 3 times, we are going to divide by 1,000. Each 0 for each step we moved. Okay, so we move 3 times, we divide by 1,000 to the power of 1 all over 3. Okay, so remember, 3 is at the denominator, therefore is a root. So we have cube root of 27 all over 1,000. We have already found out that the cube root of 27 is 3. So we have 3 here. But what is the cube root of 1,000? The cube root of 1,000 is a number that will multiply itself 3 times to give us 1,000. That number is 10. 10 multiplied by 10, 100. 100 multiplied by 10, 1,000. So we have 10. So our final answer to this particular question is 3 all over 10. Okay, this is the simple process of solving indices that contains fractions as exponent. Once you see a fractional indices, all you need to do is identify the numerator as a power and identify the denominator as a root. Simple. I'd like you to solve this classwork and leave your answer in the comment section. Okay, we have 36 all over 169 to the power of 1 all over 2. So this is a simple classwork, and I would like to see the answer in the comment section. If you enjoyed the video, don't forget to like the video, share with your friends, and subscribe to this YouTube channel for more maths content. See you in the next video. Bye.